guys, welcome to this video. We're going to have a look at integrating yet another kind of function. In this case, the most basic sort of what's called a rational function here. We've got one can be linear thing normally over another one. This is the simplest kind of rational function. Now, using this as a basis for other work is going to be important. So yeah, this is going to be quite a crucial sort of result that we need to get here. Okay, so having a look at a little piece of work that we've seen previously this year when we did some work on differentiation. What we saw was that when you had the natural log function, that its derivative was 1 over x. Now I just want to point out one thing before we continue. The natural log function, remember, is only defined where x is greater than 0. And when you have a look at the graph of that function, so let me just draw a quick sketch of it. Okay, what you would see is that it would end up looking something like this, and this is pretty rough, but it'll do. Okay, so this is the graph of y equals natural log x and y axes, and y equals natural log x. Of course, you'll be able to tell me where it goes through on the x-axis, won't you? You all know that the natural log of 1 is equal to 0. Okay, so yeah, it goes through 1 here. Okay, so that's an important result, that this is only defined when x is greater than 0. But what we're trying to look at is we're trying to look at the integral of 1 over x with respect to x, and here x doesn't have any limits. Okay, so it can be negative numbers. What we're going to do is we're going to use the pretty obvious idea that, well, if this is our starting function and we derive, well, then integrating should take us back to the natural log function. And that's true, but remember that this is only defined for positive x values, and this is defined for all x values except, of course, when x is 0, where 1 over 0 is undefined. Okay, that's a pretty basic maths result that you should all know. Okay, so what's the point I'm trying to make here? Well, while this can be calculated for nearly all x values, this is only defined for positive values of x. Well, there is a function called the absolute value function, which makes values which might be negative here positive. Okay, and so, for example, if we take the absolute value of negative 2, well, that's positive 2. The absolute value of a positive number is still positive, and of course that would also be true for decimal values as well. So we can use that function here and say, well, if this is only defined for positive values of x, let's make them positive, even though these x values here might have been negative. Okay, so there's our basic result, and of course we need a plus c. Okay, because there might have been a constant in our original function here that when we derived disappeared. So here's our basic result for integrating 1 over x. Okay, what we're going to do now, we'll have a look at about 4 examples and then get you to try, I think, 3 different questions or so. So, for example, let's call this example 1, and let's say we're after trying to integrate 3 over x, where we have a constant on top there. Okay, what we'll do is we'll use the tried, the good old method of try and check, and then we'll try and see if there's some shortcuts, especially where there's a constant that we might be able to actually take out the front of the integral, but more about that in a minute. Okay, let's try the obvious. Let's try saying the answer is 3 natural log absolute value of x plus c. Okay, well, we can check that. Okay, let's derive this to check it. So it'd be 3, and the derivative of the natural log of x, even if x is always positive, is still 1 over x. Okay, that's that result up here we got from differentiation. Okay, and yeah, when we derive the constant, of course, it disappears. Put that back as a single fraction, and we definitely have our starting function here. So this is the correct answer. Okay, what I'd like you to notice that we could have got that same result by starting with this function here and pulling that 3 as a constant out the front of the integral. And so if you do that, well, you can use this basic result more directly and you still get the same answer, of course. But sometimes it is actually quite handy to be able to pull any constant like this out the front of the integral. In fact, that can be done not only with these rational functions, but trig, exponential, or other functions. Okay, let's have a look at a second example. Okay, so let's say we had the integral of 1 over 4x. Now, once again, we'll try using the try-check method, and then we'll also see if we took a quarter as a common factor out the front, as a constant out the front, that we would also get the same answer. But let's try this for a moment. Let's try a quarter natural log absolute value of x plus c as our possible answer. Where's the quarter coming from? 1/4 there, 1 over 4. Okay, let's check that. Okay, and what do we see? Well, when we derive this function here, it's a quarter times 1 over x, derive the constant becomes 0, and yet we get 1 over 4x. So this is definitely the correct answer. So once again, note that if we had decided to take the quarter out the front of our original question, so going from here down to here for now, okay, this is going to be a quarter times 1 over x. Multiply those two together, you get this back here, this 1 over 4x. Okay, and we can use the basic result more directly once again. So it'd be a quarter natural log absolute value of x plus c. Okay, now I prefer to use this idea of taking the constant out because usually you get a much simpler integral to calculate. If you really want to stick with this try and check method for these, that's good. But I think you will find that it's actually easier to actually take this constant out the front. Right, let's have a look at an example. We can't take a constant out the front, but we still have some numbers to deal with. So let's go to a new page, and let's call this example 3, because that's the one we're up to. Okay, and let's have a look at 1 over 2x plus 1. Now, what I was saying before, take constants out the front if you can, but to do that here would be actually making the problem more difficult, really. We can't do something like this. If you take a half out the front, then what would you have to do to get that bottom line back? Well, we can have an x there, but then to get the 1 back, we'd have to actually make that a half. You know, when you multiply a half times that, would give this back here, but this is, you know, a bit more horrible to actually try and integrate. So sometimes you can't take a common factor or a constant out. Only take it out if it's sensible and possible, obviously, but also sensible. Okay, so what could we do here? Well, I think we're going to have to use the try and check method. So I'm going to try looking at, well, what happens if I simply say, let's go with this as a possible answer, natural log absolute value 2x plus 1 plus a constant. Well, when we check that, we're going to run into the chain rule here. Hopefully you spotted that already. When we derive that, we get 1 over 2x plus 1, and derive the inner part here, so times 2. So what we end up with is a 2 on top of the 2x plus 1, okay, not the 1, so we're out by a factor of 2. Now from the work we've done on exponential and trig functions, you should know that we're going to compensate for that times 2 by multiplying this try here by a half. So let's say this is our beta try. So a half natural log absolute value 2x plus 1 plus c. And yeah, check it. Derive this, we get a half times 1 over 2x plus 1 times the derivative of the inner part, which is a 2. They cancel, and you end up with what we hopefully we're going to get our starting function there. So this answer here is definitely the correct answer. Alright, let's try another one. Okay, what happens if we have a constant that we might be able to take out the front and some other numbers? So let's have a look at integral of 3 over 5x plus 2. Integrating that with respect to x. Well, yeah, I'm going to take that 3 out the front because it's certainly possible and sensible to do so. Now we've got a problem which looks pretty much like this one here. So I'm going to actually try to take into account that if I put down the answer natural log absolute value 5x plus 2, when I derive that, I'm going to get 1 over 5x plus 2, but I'm also going to get the times 5. So let's compensate for that times 5 by multiplying by a fifth. Now don't forget we've already got a 3 out the front, so 3 times the 1/5, well, that will give me 3/5 out the front. So let's put that there, and then plus c, and let's check it. Okay, so let's check by deriving. So 3/5 times 1 over 5x plus 2 times the 5, they cancel, and multiplying the two fractions there, sure enough we get our starting function here. So this is definitely the correct answer. Okay, so guys, that's 4 examples. The ones that you're going to do in class will be similar to this in many ways for this particular little section. So in the video there will be 3 questions I'm going to give you. Have a go at answering those, which should be coming up pretty soon from now.